On.
Okay, today we're going to graph rational functions. I will be back Monday and I'll be able to answer some questions about this, but I do expect you to learn this and really go through the steps today. Concentrate on the steps that you have on your paper. Concentrate on the steps that it says right here. It's all stuff you know how to do. Step 1, we're going to factor the numerator and denominator first. Like all rationals, factor first. X squared plus 2x minus 8. Two numbers that add to 2, multiply to negative 8. X plus 4, x minus 2. Over x squared plus 9x plus 20. Two numbers that add to 9, multiply to 20. X plus 4, x plus 5. Now looking at our next step, we're going to solve our denominator equal to 0 to find our vertical asymptotes and our holes. So we have two binomials here to solve equal to 0. We have x plus 4 equals 0. Subtract 4, x equals negative 4. And x plus 5 equals 0. Subtract 5, x equals negative 5. Now if we cancel these, x plus 4 would cancel. That means that x equals negative 4 is the x-coordinate of our hole. We can't graph that yet because we don't know where it's going to be on the function. But that's going to be our hole. X equals negative 5 is our vertical asymptote because that does not cancel. Now we're going to use our rules to determine our horizontal asymptotes from the unfactored numerator and denominator. This is based on the degree. So looking back at the rules that are on your paper, horizontal asymptotes, the degree of the numerator and denominator are equal. Remember, degree is the highest exponent. The highest exponent of the numerator is 2, of the denominator is 2. So when they're equal, we take the leading coefficients. Degrees equal. So the horizontal asymptote is that y equals, leading coefficient of the numerator is 1, leading coefficient of the denominator is 1, 1 divided by 1 equals 1. At the end, we'll graph all these and we'll show you how they apply to the graph. Step 4 is set x equal to 0 to find the y-intercepts. So for that, just make all of our x's in our original function 0. 0 squared plus 2 times 0 minus 8 over 0 squared plus 9 times 0 plus 20. Negative 8 over 20, and we're going to write it as a decimal, negative 0.4, because that'll make it easier for us to graph. Set the numerator equal to 0 to find your x-intercepts after you cancel your factors. So x plus 4 is going to cancel. X minus 2 equal to 0 is going to give us our x-intercepts. When we solve this, add 2 on both sides, x equals 2. So now we'll start graphing everything. Like I said, we do have to wait till the end on our hole. Vertical asymptote is that imaginary line that our function approaches but does not touch. At x equals negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. And we're going to represent it as a dashed line. Our horizontal asymptote, same thing. It's going to be a dashed line at y equals 1. And it's horizontal, so it goes across. Just like that. Our intercepts. Our y-intercept at negative 0.4. So we're going to go about halfway down to the negative 1 on the y. X-intercept at x equals 2. On the x-axis, we go to 2. Now we have to graph into our calculator to get our shape. So let's go to the calculator. A couple key things to remember here when we graph it. First, we're going to graph it from the original function. And second, we need to put the entire numerator and denominator in parentheses. Remember, the fraction bar is a grouping symbol. It's like putting the whole numerator in parentheses, the whole denominator in parentheses. So, parentheses, x squared plus 2x minus 8, close parentheses, divided by, parentheses, x squared plus 9x plus 20, zoom standard, like we always start our graphs, and zoom standard. And there's our graph. Now you'll see, on here, my graph actually shows the vertical asymptote. That's not mathematically correct. The vertical asymptote is not part of the function. This is just an old calculator that does that. These two curves represent our rational function. So if we go back to our graph, we'll put one curve here, approaching but not crossing our asymptotes, and one curve here, going through our intercepts and approaching but not crossing our asymptotes. Now our last step, we can't forget about our hole. At x equals -4, our function has a hole. So -1, -2, -3, -4. Wherever our function is on this line, right there, we're actually going to put a hole in the function because there's no value. And we'll make a little hole. That's the graph of our rational function. Now try the next three, going through all the steps, using those rules, and give them a shot. Please don't come in tomorrow and say, or Monday and say you didn't know how to do it. You do know how to do it. You need to be willing to put the effort in to do it. And you can. Good luck.